Greetings everyone, this is Mr. Mullen. In this video I'm just going to briefly show you some ideas to keep in mind in questions 1 through 4. Actually I want to start with number 2 first because question number 2 is actually the question that should have been written first. It says how much energy must a mole of hydrogen atoms absorb if the electrons are to move from the first energy level, n is equal to 1, to the fifth energy level. And so for this problem here it's asking you how much energy must that little electron absorb to get from that first energy level to the fifth. Okay, so my little electron is going to be absorbing some energy to jump in energy level to the fifth one. And I wanted to find out how much energy it's going to take to do this for a whole mole of hydrogen atoms. And so you're going to need to set up, like we did in the notes, we're going to go to the fifth and the first energy level. We're going to use that equation that the energy is equal to the R over R is that constant for hydrogen. We're going to be using that 1312 kilojoules per mole. That's the constant for hydrogen, and divided by n squared. So you're going to have two little equations set up there. So that amount of energy that you're going to be calculating, like we did in the notes, you're going to take that R value and divide it by n squared. N squared here would be 25. 1 squared is just 1. And you're going to be calculating the energies. And so once you have the energies, you're going to get your new difference between the two. You're just going to subtract them to get your energy change. And then that energy, you should be getting an energy change in kilojoules per mole when you get a final answer there. Now, question number 1 is asking for a specific hydrogen atom, just one little atom. And it says if it increases in energy level from first to the fifth once again. So it doesn't matter whether it's absorbing or releasing energy, it's still the same amount to go from the first to the fifth level. So for this one you can actually use your answer from the previous problem. And I'm just going to make up a number. Let's say you had 10 kilojoules per mole. You calculated. You need to get that in terms of one atom, or one atom can emit one photon at a time. So if you rewrite this as kilojoules per mole, I'm going to ask you to rewrite it in this way. 10 kilojoules per 1 mole. And now with my units, my goal is going to be to do some steps to get to at the end. Joules on top. Not kilojoules, but joules on top. And atoms on bottom. Okay, atoms. Or we talked about in class, I'm really talking about there's one photon per for each atom. So you want to come up with a couple of conversion factors to transfer out of kilojoules to joules and from moles to atoms in the denominator. Question number 3, there's a little bit more for number 3. You're going to be going from the how much energy is given off or released from one hydrogen atom as it loses energy from level 3 to energy 2. So we're starting n equals 3. And so this is kicking out energy as it falls back down from its excited state. And so you will have in your little calculation, you'll have some number up top here on these fractions, and 3 squared is 9. You'll have your R value there. 2 squared is 4. And you'll figure out what your new energy, or what the energy is of each, at each one of those energy levels. And then you'll find the difference between those. And for number 3, you're going to get out another answer in kilojoules per mole. And you're going to be converting that again, just like you did in the last problem, all the way to joules per atom. Okay, like you did in number 1. And so it's very similar. You're just doing both 1 and 2 into one problem. And then number 4, there's a lot of things going on. It says, what is the frequency of electromagnetic radiation emitted when the electrons of 1 mole of hydrogen atoms change from the 4s orbital to the 1s orbital? So now some of these quantum mechanical ideas are slipping in here of orbitals. And so 4s orbital is just it's a place where electrons live in that 4th energy level. And so we're really looking at going from energy level of 4 down to 1. Okay, so it's going to give off energy. because we're talking about light, for this one here, we're going to, kind of a step-by-step. First, we're going to, find the energy using the same method we did in the last couple of problems. Once we have the energy, our goal is to figure out what kind of light it is. And so we have to calculate the frequency. Okay, find the frequency. Because it's light, same speed of light, we can use our equation dealing with frequency and wavelength. And once we find our frequency, find energy is equal to h times f. So we're going to find our energy. Once we find the energy, we're going to find our frequency using our equation with Planck's constant. We're going to have to use that alternate Planck's constant we derived in class. And then once we have our frequency, we can use that to find the wavelength, or just take the frequency and figure out what type of light it is. And so we're going to find the frequency, then we can find the wavelength using this equation. Find wavelength. And once we know the frequency, we actually are going to be able to figure out what type of light it is. And so you can go look at that little table. Once you know the frequency and the wavelength, we can figure out what type of electromagnetic radiation or what spectral region it appears in. Alright, so this has been just kind of a brief glance at some of these questions. And if you want to look some help, number 5 and 6, take a look at that other video. And I hope that this was helpful.